Welcome to everyone to this Oracle Groundbreakers APAC Virtual Conference 2 presentation. So in this presentation, we're going to talk about in-database machine learning with Oracle Autonomous Data Warehouse. Just a little bit introduction about myself. So my name is Kai Yu. I'm based in Austin, Texas, in the US. So I work with Dell for the last 20 years. I'm current title is Distinguished Engineer. I'm responsible for Dell Oracle programs. In this program, our goal is to establish a best practice and also help customers to best leverage Dell infrastructure such as Dell server, networking and storage for Oracle database workload. We also study how to run the database related application on top of Oracle database, such as Oracle EBS, and also we also study cloud and virtualization. And in the last few years, I spent some time working on the business analytical and also machine learning, specifically in Oracle database. So I also spent some time to work with the Oracle global Oracle community, and by presenting, sharing a lot of my experience. So since last 14 years, I made about 190 presentation. So I also joined the Oracle ACE Director program in 2010. So this is a very great program. So in this program, we get a chance to meet or share knowledge with the global Oracle community. So I also have some time, get a chance to co-author some book with other ACE Director. So the one of the book was Oracle 12c. So we are also currently working on the Oracle Machine Learning books. So the goal is to publish this book early next year, end of this year or early next year. So in today, we have a few topics around this machine learning topic, the technology. One is we want to discuss the machine learning, how we do machine learning database, why we need a machine learning database. And then we're going to focus on specific Oracle database, that's a cloud database, that is an autonomous data warehouse running Oracle Cloud, Oracle OCI. And we also want to talk about specific focus on the machine learning, how we do the machine learning in ADW, autonomous data warehouse, and how to leverage some specific feature with ADW for machine learning. Then we're going to use one example to go through the entire process to build a machine learning model and apply that model with Oracle Machine Learning in ADW. So first of all, let's look at the machine learning in database. So as we know, when we have last 20, 30 years with Oracle database, one of the big application is data warehouse. So it is very common that all the business, in addition to their transaction database, they also have they build data model, build data warehouse. The one of the reason to build a data warehouse is that they're going to use a lot of historical data or even online data to make a report and make a dashboard. So for the business, so those report dashboard can report how the business was doing in last quarter or last year or recent quarter. So that is very basic data warehouse features. Then in addition to those reports, a lot of business try to use the report to do some diagnostic, such as So for example, if if we found that in last quarter there's a business there is actually reduced sales, and they can use those reports to do some diagnostic analysis and find which part is behind. Then, first of all, they also want to use some historical data to predict the future. So, for example, they may use last year same quarter data to predict the same quarter this year, predict sales, and they also because if they can predict sales, they actually can do a lot of other things. For example, they can based on the prediction of the sales, they can predict how much parts they can get from supply, and how much investment they need, and how much labor resource they need to hire. So that's very important. And furthermore, this is actually the prediction is already kind of getting into the machine learning areas. So then next phase is those prediction and the machine learning features. They also want to build into some existing application. So for example, if they have a business like a supply chain application, they can get a prediction for next year. They automatically use the supply chain application to leverage the prediction, so they can pass this the business supply chain application and made a request for next quarter, how much they want to how much parts or how much material they should acquire. So in this case, we want to have machine learning building into the application, and one of the important requirements is this machine learning has to be, the process of machine learning has to be automated as a part of an entire business automation process. So you can look at it, this machine learning is actually natural maturity of the business analytical application. So, and the same, if we look at it deeper in a lot of business, it is related to machine learning. So for example, pattern discovery. So you have a lot of time the business tend to use a lot of historical data, large set of data, find a pattern, or make a prediction, predict what's the future based on some historical data. So for example, they can predict next quarter what's the probability that we could have better sales. So, and also another problem is grouping. So they want to find out, to recognize, from different picture, they want to automatically recognize what are pictures for human, what are pictures for car or for building. So to help machine to recognize this, for example, in the self-driving, this is very important to recognize the project in front of you. So another area is called actionable information. So for example, you can use machine learning to actually make based on historical data to make a decision. So for example, to approve credit card application, so you can based on the historical data to make a decision about one specific customer for their credit card information, credit card application, to determine whether or not this customer have a good credit, can potentially have good credit score. So then we can make a decision whether or not we can grant them the credit card application. So those are the very common business problems that may relate to machine learning. So overall, machine learning has two different categories. One is called supervised learning. So for example, one of the characteristic of the supervised learning is we know the knowledge about the target also attribute. So for example, if we have a set of data that for all the customers that with their customer financial information, sale and salary or accounting information, also family history. We also know their credit score. So those are non information. We can use those information, build a machine learning model, so that we can use that model to predict the new customer who we don't know their credit score. So we can use their financial information to, and based on the model we learn from all the non-data to predict the new data, the target, in this case, credit score. So if we, those, some of the very famous supervised learning, including attribute importance, classification, and regression. So one of the classification example is we need to determine whether or not the target is has a good good value. For example, the credit card score should be good. They have good score or bad score. Another area of the the machine learning is called unsupervised learning. In this case, we don't have actually non-data. So for example, if we want to recognize the lot of picture, the cat, the dog, we don't know which one is dog, which is cat. So we use a lot of machine learning model actually to kind of to classify them, clustering them, so make a group, like this group of picture is a cat, this group picture is dog. So we don't necessarily have the non-data, but we can group them. So this the part of some famous supervised learning example are like anonymous detection. So for example, if you have the system monitor the lot of pipe or you collect a lot of data. So you need to have a machine learning method to identify if there's any anomaly. So there's some data you collected, you can identify from thousands of data you collected, you are able to find one or two abnormal data. So you can reach along. So another example is called association rule. So for example, in marketing, you know, marketing term, you want to find out when customer buy something, they normally buy together. So for example, if customer buy a laptop, they most likely they also buy a mouse together. So those are the learning. And also grouping, we just talk about it. So a lot of time the learning is machine learning is based on a lot of data. So we have a huge set of data X, we want to predict Y. So and a lot of time the X has a huge set of data. Like in our example, maybe small a number like 100,000 or million row, but in reality, the data maybe like billion rows. You based on billion row, the data set, you build a machine learning model. The one big problem is those data are normally a lot of time data sit in database. So if we want to build a model, running the model building is separate the machine learning algorithm which run in different server. Then every time you do machine learning, you actually have to move those data from database to the machine learning server. So that causes a lot of delays, and also because sometimes in your source data you can update the source data when you are building the data model, machine learning model. Because your moving data may take like hours, 2 hours moving data. Then once you got data to the machine learning side, your data is already too old. So in this case, why we instead of moving the data to the machine learning server, why we cannot move the machine learning program or algorithm into database? So in this way, you can always get access to the latest data without any time delay, also effort to move the data around. So actually, Oracle has already done this work since like 10 years ago. So back to 10 years ago, Oracle has this called data mining module. This data mining module is able to handle most machine learning problem, and they present most machine learning algorithm. So this is actually a picture of all the machine learning, most common machine learning function algorithm that is supported by the machine learning, the data mining, the machine learning, data mining package. So now in 19C, Oracle pretty much renamed this data mining into Oracle Machine Learning. So that's the origin of Oracle Machine Learning. So now today we see the Oracle Machine Learning is building Oracle database. So they provide two kind of important things. One is a pure SQL procedure. So the way the Oracle offer machine learning is called Oracle Machine Learning for SQL. The Oracle Machine Learning for SQL cover all, they support all the most common machine learning algorithm, but they also provide the DBAS data mining package to support machine learning programming. They also use they also have an Oracle SQL function as an extension of the SQL, Oracle typical Oracle SQL to cover a lot of machine learning requirements, such as how to apply model. So we're going to discuss more later on. So basically, Oracle integrated all the machine learning across the Oracle stack. So there's a very good benefit for that. That they can help data scientists or developer build their machine learning algorithm, the application inside Oracle database. So by doing that, you don't have to move data around. And also Oracle is actually building a lot of tool for the data scientists to do the data preparation, data exploration, and the one of the good tool to do data exploration is actually SQL language. So you can get a SQL, you can select all kind of data from tables, and process some of the notebook feature that we're going to talk about later on. This will provide data scientists to export data and also look at data in different graphical way. And there are a lot of statistical function built into notebook, so that data science can leverage. And plus the Oracle Machine Learning for SQL support the most common algorithm, the machine learning algorithm. And Oracle is also working on the R or Python wrap outside of the database. So for data scientists who know R or Python, they can continue write the Python program to do machine learning. But Oracle actually prepare a layer of the interface with Python and SQL language, so that suppose the Python program will eventually be converted to the SQL language and gonna execute inside of the database engine. So yeah. So this is an example that Oracle Machine Learning for SQL example. So you have this pure SQL package, the database DBMS data mining package. This is the package that has many different functions. The create underscore module is one of the functions that we can use to build a model, and another advantage is the SQL function. So the prediction, like this SQL function, prediction underscore property, that's the one of the SQL function that actually can use model to predict the new data. So in this case, NY class 1 model is actually model, and then we can those are the new record. Like for example, I want to use this model to predict the customer who has such a $2,000 income and the level of the silver level in the customer value segment, and also the wealth is wealth and is market as rich. For this customer, we want to predict what is the probability of this customer that has good credit score. So this is actually the actual SQL function to apply model to a specific customer, and the result is to get a probability of of this customer for being the good to having the to have the good credit. So with another good area, good advantage is by doing the Oracle by having all the machine learning running inside Oracle database, we can leverage a lot of the parallel distributed algorithm. For example, we have Oracle multiple Oracle node rack, and each Oracle database has usually most Oracle database has a very good CPU resource. We can, for example, we have a 48 core CPU, 96 core CPU. So we can distribute workload in parallel in the multiple CPU environment so that we can do this machine learning in very efficient way. And also another great advantage is the lot of machine learning in database machine learning data structure is based on table. So for example, once you build a model, the model is actually saved as a table. That is very convenient way because if you have table, then we know we can export import a table, and we also can grant permission to that table. Those are all our mature technology, so that we can basically transport that model to different environment. So for example, you can finish when you finish the model training in one database, then you can export it and import to another database to do the model application. So that is actually quite important because many times the environment that you apply model may not be the same as the environment you apply model, your training model. So for example, one of the cases is the self-driving car. So you want to build a model based on a lot of data. So you build a model in car environment. Then when you apply the model, you actually apply the model in each individual car. So that's why you need to actually ship your model, download your model from the cloud to the edge. Edge, in this case, it is your car, individual car. So it's very common. It's very common you actually ship model around. So by having the model stored in the table, the download upload model become very easy. Okay, so let's look at a specific environment called autonomous database and how we build a model. So Oracle Autonomous Data Warehouse environment is actually built on Oracle OCI infrastructure, so Oracle Cloud infrastructure, which means that you can take a lot of advantage of the greater infrastructure such as compute storage and networking environment. And the Oracle Autonomous Database is actually built with these three different goals: self-driving, self-secure, self-repair, repairing, which means if you want so this database is pretty much run by itself, provisioned by itself. So only thing you need is make it, specify how much capacity you need. So for example, how much CPU, how much memory, how big database you need. And that's it. Then the cloud environment, self-service cloud environment will provision the database for you. And after you have database, you don't have to worry about the backup or monitoring. So all this has been taken care of by the autonomous feature in backend. And so autonomous database basically are designed to run two different workloads. One is ATP transaction processing, one is autonomous warehouse. So that's why the autonomous database it has two different setup. So data warehouse setup and ATP setup. And they also implement different tuning parameter in each of these databases. So when you want to provision your database, autonomous database, you need to specify whether you want an ATP or you want an ADW. So we take a ADW as to talk about the machine learning, because we think there's a lot of similarity between the machine learning and data warehouse business analytical environment. But actually, ATP also support machine learning, but we think the ADW is most common use case for machine learning. So let's look at autonomous data warehouse environment. So autonomous data warehouse environment, autonomous data warehouse itself has the same database kernel as a regular enterprise with addition database. So all the machine learning feature we talk about it is already there here. So in addition to that, you also have machine learning has a set of built-in query or application development tool. So you have a SQL developer web-based and also application experience or REST data access. So if you want to build some simple application, definitely you can just the only thing you need is a browser. You can connect to this environment to build application. Of course, you want to leverage your database schema data inside autonomous database. But today we want to focus on one different tool that's called machine learning tool. That is a tool that actually build outside of database that allow you to actually speed up your machine learning environment, the development environment. It'll present the lot of GUI kind of data analytical tool, and also the graphical tool for you to do data exploration. Also, the data mining tool itself, data machine learning tool itself, is just like a SQL development tool. They actually allow you to write SQL and also write SQL, write PL SQL package, execute against your machine learning data warehouse instance. The connectivity between the machine learning tool and the autonomous database is already pre-built inside. So yeah, so machine learning also, if you want to run some application, if you want to develop some application using data warehouse, you also can use your environment in your on-premise or even your laptop. So you can connect your database. You can establish your database connectivity from your data your application server, whether in laptop or your data center, connect to the autonomous database. So you have an option. You can either use their built-in tool or you can use all the client tool you have on your machine, on your system to connect to your database. They use a regular SQLnet, JDBC or DBC application connectivities. So if you are interested to try the ADW, so what you can do is you can go to Oracle Cloud interface, cloud infrastructure, sign up a free account. That's something I always recommend you start with. Something you start with. So when you sign an account, they automatically give you $300 free credit for you to utilize, different resource, CPU or storage or networking, because all those actually not only cost you the credit to build it, they also cost you credit to run it. So if you want to try something, you can do it. But my advice is you can try something. Let's say if you try something, if you like go off the work, you temporarily want to suspend this, you can shut down the database. So because if you don't shut down the database still keep running, even it's a minimal usage, but still charge you. So your $300 could use quickly. So you can shut down database. Once you shut down database, they're not going to charge you. But even you don't use it, but after you 30 days, still the credit is gone. So after you use the credit, or you already run up to 30 days, what do you do? So you have two options. One is you upgrade to pay account. So if you really have this need to keep this for example, if you want to develop some business application, or you're going to move your corporate database into the cloud, yeah, definitely you need to upgrade to the pay account. But if you just want to try something feature, including machine learning feature, like today, those example I'm going to show you, you could just continue use free. So if you don't do anything, that's free. So that's always free account. But if you do always free account, then there's actually limitation. So this list are available for you. Pretty much you have all the things available for you, but you're only on small scales. The machine learning function, all the machine learning functions are available for you under always free account. So limitation is you only have one CPU in your database. You could have two databases, either one for each or two for each for any of these. And you only can maximum have 20 database connections. So if you don't use database 7 days, they're going to shut down the database. If your database has been shut down for three months, they're going to reclaim your database resources. So here's some steps you can quickly provision Oracle database. So you log into, once you get a free account, log into your account, and come to here, you click Autonomous Data Warehouse in Data Warehouse. Then they're going to ask you whether you want to try Autonomous Database, ADW or ATP. Then if you select either one, then you specify the database name, how much memory you need, and how many CPU or how big database you need. Then you want to use serverless or not. So most likely you will be using serverless. So the free account doesn't have a dedicated infrastructure. So then the database take 15 minutes, depending on the size of the database, take 10 to 15 minutes to get the database up. So this now its database is up. You can start using the database. Okay, so then once you have database, let's look at how to leverage the specific Oracle machine learning feature with ADW. So as we discussed, the ADW coming with a set of tools. The specific tool, they call them Oracle Machine Learning tool. It's an online tool, and that actually is based on the Apache Notebook. So this is a web-based tool, so you don't need any kind. Only thing you need is a browser. You can connect to this tool, and all this tool, and naturally this tool connect to your Autonomous Database warehouse, and this tool also give you a lot of GUI feature to look at data. So the important thing is notebook, and also all the machine learning algorithm API is already pre-built inside of the Autonomous Database. So you can call those API or algorithm inside of a notebook, the Oracle Machine Learning Notebook. So as we discussed, same, the ADW is also shares the same database engine as an enterprise database. So it supports all those SQL function or PL SQL function that support all those algorithm, machine learning algorithm. So here's a little bit about the new feature that we are expecting Oracle to add in. This is actually the screenshot I got from last Open World. What is the new feature they're going to add into Oracle Machine Learning? So there are some extension, including Python R. So for those people who are more familiar with Python R, this is the extension is important for them. So they can use Python R to call this database machine algorithm, all the machine learning algorithm. And another important feature is called AutoML. So as we discussed, it's important that we should incorporate the machine learning into enterprise application. So that's the only reason you want to have that, right? But in order to have to be able to incorporate with the a lot of automated software. So you gotta make this machine learning as much automated as possible. So less manual work. So one example is there's a couple important the area that is so critical for the automation. One is model selection. So the algorithm should be smart enough based on a program to select the proper model. So the human being doesn't have to make a selection. They based on business program. Second is we should have automation to pick those important features for the machine learning. So a lot of time, the data warehouse environment, you have a big fact table. That big fact table has 40 or 50 attributes in this column, and most of the time, only probably like 10 handful or less handful of the attributes that really are significant for prediction for machine learning. The rest of it is not that, the impact is not that small, not important. So it's important for us to select those critical features by reducing the number of features we use. This also improves performance because the more feature you use for machine learning, the more resource you need, a longer time for you to build the model. So it's important to only select the most critical feature, and it's also important to have this capability automated. Second thing is, the third thing is a lot of time the machine learning model, the algorithm has tons of parameter setting, different setting. And those setting is critical for machine learning accuracy, but it's a lot of setting, and it's very difficult for manual to set those. And a lot of times, manual the human being just no idea what setting should be. So it's good to have some intelligence built in to tune those settings. So those are the area that the supposed to happen to be added into machine learning in Oracle 20C. So, but we still have not seen that yet. So because Oracle 20C has not been released yet. So hopefully next year we'll see the 20C or 21C that has all those features. Okay, so in order to access the Oracle Machine Learning Notebook, so you need to create a database user in database and grant them the developer privilege. In this case, I log in the Oracle Machine ADW database instance and create a user called ADWC_WS user. Then grant them the if I use this window, automatically grant developer privilege. So once this user has developer privilege, then I can use this user to log into ADW, the machine learning tool that with this database, ADW database. So this is actually the web-based. So this is a tool that available in web-based. So once you log in, you are able to create a notebook. So this is the button to create a notebook, and also these are two specific notebook, SQL, the SQL notebook or the SQL script notebook is different. This is for select statement. This is for select to run pure SQL package. But these two are actually changeable. So if you open the one SQL script, you run for a while, then if you run a SQL, you just put different prompt. We're going to show a different prompt. SQL is a script. SQL script has a SQL script prompt. SQL has a SQL prompt. So another thing is an example. That's very important. By click this, you will see a lot of different examples that you can learn. So I will recommend that you, first time, if you are first time to start learning this, then try go through some of example. So you will get an idea how to, you will get an idea to know this different algorithm. Also, you get an idea how to go through this process. But we're going to show you later on. We're going to show one example how we build machine learning. So this is actually the notebook, how the notebook looks like. So you can write a SQL. It's just like a SQL developer. You can write a SQL. You can click this icon to run the SQL. Now, once you run the SQL, this is the result. By default, this result is in this table format. But this notebook not just give you table format. Otherwise, it will be same as a SQL developer. Those are the great feature that for you to look at the data a different way. So we have, for example, if we want to see the pipe, so we can click this pipe. This is the pipe icon. Click this, they're going to show the data different way. And also, if you want to show barcode, bar chart, so I click bar chart. Then I also can look at data different way by put a lot of statistic function into it. In this case, I want to group by the one of the column. So this is selection. I want to group by this column to see by each of this category how many customer are in each category. So this is just like a select star from group by, but you don't have to write it. So you only thing you have to do with SQL is just one big select statement. By click of this, the notebook will do the statistical calculation for you. Okay, let's quick jump into the example. So I want to show you how to use this capability to build one machine learning example. But of course, as we mentioned, if you click the example button, you can see more examples. So this example is actually one of the Oracle example called custom score prediction. So they're going to base on the data that on this table called the custom credit table. So this table has about almost more than 40 columns. And so all these are attributes: customer, age, income, tenure, and also occupation, and credit amount, all those. And also, we also have each customer, it also have credit score. So credit score could be different numbers, like 500 or 501, 100, maybe 300, or maybe 700. But instead of putting the concrete number, we actually put it into a different range. In this case, we can bin. So for example, we put it like from 200 to 250. So one range. That's in one bin. 251 to 300. That's another bin. So that's how for all the continuous number, Oracle Machine Learning prefer you first bin those data. So instead of you have too many values. So if you have too many values, it's make the more bin you have, the more complicated for machine learning to calculate. And in this case, we actually bin only for good or bad. So let's say, for example, we said that any score below 500, we think it is bad. Any score above 500 is good. So we only bin 2. So this actually makes sense because when you prove credit card score, credit card by score, only thing you need to know is this customer have good credit score or bad credit score. So you don't need to know is 499 or 500. So we just only thing we need to know is based on all the customer information, we want to determine if this customer may have good credit score or bad credit score. So this normally machine learning has two different phases, major tasks. One is to gather all the data, prepare data, export data. So this is all the data preparation. Then based on data preparation, we build a model. Then we actually review the model, can evaluate the model, make sure the model is correct. Then we apply this model. So those are two different phases. So let's double click to each of this. So for the first phase, we first prepare data. So let's get a prepare data. So a lot of time, the data could be distributed on several tables. machine learning, one of the requirements for machine learning is your base data is one table or one view. So, so if you have the data spread into different tables, join them together, make a view like this. So in this case, this view doesn't have join, but if your table, if your data base data is on several tables, can join it, create a view. Then you pass this view to base table as a base table to the machine learning algorithm. Second thing is we want to understand data distribution by exploring some data. That's how this all the statistics or graphic come in to help you. And this is the area that actually most data scientists is quite familiar with. So the only thing we need is this machine learning tool provide the capability. So in a way that data scientists know. So only thing they have to know is, in this case, is write a select statement. Then how you look at the data, which is most data scientists are actually quite familiar with this, because notebook, a lot of time, the notebook itself is not database tool. It's already independent from database. So for some notebook, they can get the data, use other Python or language to get the data instead of SQL language. Then they can use those GUI or statistics function to look at data different way. But now the Oracle Machine Learning tool just allow your notebook, just allow you to combine the SQL and also the GUI graphic representation plus all the statistics application in the single tool. And this is another way we want to look at it. By the data, by giving a 100,000 raw data, the non-data, we want to know how many, what is distribution of good credit, how many people, what percentage of people have good credit, how many percentage of people have bad credit. In this case, you can see probably 20% is good credit, another 80% is bad credit. That gives you some perspective. Okay, we just mentioned the bin. So not only the target, such as credit score, we need bin. Some of the other attribute also needs bin. For example, age, the 20 years, 25 years, 22 years, so instead of calculate each of the 8 years, we bin them together. We can make classify them 10 bins. So we really don't need to know what exactly the age. We just feel like just need to based on the bin. If this customer is bin 2 or bin 3, so that's all we need to know. And then we, based on the bin, we can actually do some analysis. See in each bin how many customers, what's the data distribution. Like for example, bin 1. We'll have 110 customers. Bin 2 has 100 customers, maybe 95 customers. So this is how you actually can use this tool to display. Okay, then we also Oracle Machine Learning for SQL also provide you another function called predicative analysis. So this allows you to actually find it, do some simple calculation. Sample calculation to understand those attributes. For example, in this case, I have 40 attributes, but I want to know what is our top, what are the attributes that are top attributes that influence the target value. So in this case, my target value is credit score. I want to know for all the 40 attributes, what are top attributes that impact credit score. So we actually can call this function to do it. So this is the base table. And this function will do analysis based on table value, and then put all the result into this result table. Then once you finish this PL SQL procedure, you can run this query to understand what are top attributes. So in this case, this actually lists the top 7 attributes. So that's actually important for us to understand what are the most top influence attribute. Okay, so this is another target. So in this target is called most expanding account. So for customer credit information, the credit company wants to know may want to know two things. One is your credit score. They want to make sure you can have good credit, so you can eventually pay all the debt. You don't just go away. Second thing is that they also want to know your buying power, how much you're going to spend with your credit card. So this maximum spend amount is actually also prediction. So so of course they want to have the customer that has a good credit score, also very high amount of spending power. So those are preferred customers. So now we do the first data analysis. We know exactly data distribution within it. Then now we are ready to do the training. So before we do training, we need a sample data. We can split your your non-data into two parts, split data. So as training data or test data. So it is important that we split its data by random. So we don't split like the first 60% row, beginning of the table to one part and the last part of the table into separate part. That's not good. Also, you don't want to split all the data customer that are in the farmer into one table, all the customer and like lawyer into another table. So that those are not good representative of the data. So either use training or data or testing are not good. So it's important that we sample this data randomly. We want to split in the 60-40%, 60 by 40, but we want to show that we select those 6% data by random. So now we prepare data. Then we are ready to do the machine learning, build a model. So we decided based on the function, we decided we're going to use. We recognize this function is called classification. We are ready to use classification, but we also use the. There are several different algorithms to implement classification. In this case, we selected the the algo decision tree algorithm to implement that. And for this algorithm, there are many parameters, which is mentioned. So some parameter at default could take a default, but if you want to tune, you have to try for a different setting. That's where the machine auto ML is important, because those numbers sometimes for new beginner it just don't make much sense. You actually don't know. So so you can start with default. Then we find that if machine learning model is not good enough, you probably have to tune this parameter, try different time. Then it's many different going back forth process. So this is just an example. We put a one set of arbitrarily put a one set of setting, and then we call this a query model function. So this is actually syntax. So first one is machine learning model. This is a table. So when you finish it, when this function completes, they're going to put a machine learning model to create a model inside this table. Then the second column is what algorithm you use. In this case, I'm using classification. And then this is training data. And this is kind of actually custom ID. You always need one column that attribute a unique identified case. In this case, the unique case is custom ID. Then my target, what's my target? So the target is the credit score. Then this is actually setting all the machine learning algorithm setting is put here. Previously, which is the insert statement. Put all the insert is always like a value. So only have two columns. Attribute name and attribute value. So then we call the model. So we call this function. Once this function complete, they're gonna write it into this result, the N1 test model, the creator model. So when they finish it, N1 class model test the model. The next phase is we want to do the model evaluation. So, so this is the diagram to use the model evaluation. We input a class model, we put test data on that. Then based on this, we can apply the model into test data. Then we'll come up with a result. And they also come up with another thing called a lift result. So this is the things we look at to evaluate how good this model is. To evaluate this model, we call this called DBAS data mining compute lift procedure. So this procedure take the result, apply result, and take a test data, and put other parameter in. So so then and the result of the procedure is they put in the N1 lift table, and this is we're going to use the data inside lift table determine whether or not this result, the class model is good enough, it's accurate. So this is based on the called gain chart, lift chart. It's a very classical statistical function. So idea is we want to compare this lifted result from this model with random number. So this red line is random number. If you don't have any knowledge, you just take your guess. That is this number. But the green one is the best. It's a real data, 100% true. Then you want to make sure that your result is as close as real possible, as far from the random data. So your number, in other words, this curve is better. Yeah. So this is actually, in our case, this is the result. You can see it's better than the streamline, and it's not 100% best, but it is actually shows some good accuracy. So if you feel that this is not good enough, now we have to reassemble data or also change the parameter to see this is always you can go several runs to compare which one is best model. Then after that, if you feel this is good enough, then we can use this model apply the new data. So now we have this new data, credit score new data. So let's see, after you train a model, you have another 100 customers who want to apply credit card. This customer provide all the information except the credit score. So you are using this. You are going to use this model to predict whether those new 100 customers have a good credit score. So prediction is coming with the probability. So first they will tell you, this is actually SQL query. We just talk about it. Compare. So they're going to use this model apply to your new data, and then they're going to see if this is each of this new customer has good probability that has good credit, has a probability of good credit. So they're going to calculate the good credit. So this query will come up with a probability for each customer. And so this is a single query, but if you want to put this query in a single table, you can do that. So you just create a table as selected this big query. Then this table will have a probability column. And this actually show for each of the customer what's the probability to have good credit. So this is a single query, there's 700 rows. So some of top one are sorting by credit by the probability. So top one are those 100. So there are some of them maybe low numbers. So let's say if we decided the probability 70% is aligned. So anything beyond above 6%, we give them credit card. We approve credit card. Anything below the 70%, we reject their credit card application. So this is so by applying this function, we actually predict all their credit score by using the probability. So And this was a batch job. But if you have a single query, let's say if your application is streamlined, so you have an application like, for example, self-service application. If someone come in to apply a single record, apply to credit card, they can fill out the credit card information, their income or their wealth information. Then this single select statement will calculate the, 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 the prediction, the probability of this customer for having the good credit. So in this case, this query, the single query run in your notebook to come up with this number. So this number is 0.5. So we'll decide if we decided anything below to 70, 0.7 is not good. So in this case, this customer may not be able to pass this 70% 0.7 the mark, so that this customer may the credit card application may get rejected. If for another customer you can figure out it's like 71%, 0.71, then 72, then this customer will get approved. So which means with the N1 class 1 model, we can build in this query into any enterprise application, like for example, the credit card approved application. So that's how the part of automation. So we're building the machine learning application, deploy this application, machine learning application into a business application. So you can come up with quite a score. Otherwise, you have no way, because any existing application, if you want to make any determination, they need to go to database to select a column. In this case, probability, you don't have that data. That data is coming from machine learning model. So this is one step above any current business application. So if you write any business application, most logical is if you want to make a decision, you go to database, select data, and based on the data, make a determination. But this is the actual function that use. Instead of go to specific column to get the data, you actually use a function to calculate that data. And that function is based on the model. So this is actually how we deploy. We touch a little bit about how deploy the machine learning model in business application. So this is kind of a summary. Pretty much you conclude all the topic. So this summary, we talk about why we need it, do machine learning inside database, how, because we have Oracle already have those machine learning algorithms supported, algorithm building machine learning for SQL language. And then we also can do in addition to the support for those machine learning algorithms, building into OML for SQL, the Oracle Machine Learning for ADW also provided the notebook with all the GUI features that allow you to do data exploration. At the same time, you also can call the machine learning algorithm inside Oracle database. So these two together make a perfect environment for you to develop Oracle machine learning in the ADW environment. Then we use one example to go through the process. So that is the thing I want to cover. And there are a few references you can use. There's an Oracle machine learning white paper. There are quite a few machine learning and hands-on workshop. You can go through this. And and also looking for the Oracle 20C machine learning the manual. There are even more detail about that. And also feel free to email me if you have a question. And also welcome to my blog. So go to Google, search KAI1U and Dell or Oracle, you'll get my blog. So I have all my presentation and last 190 presentation into this blog. So that pretty much concludes my presentation. So thank you very much, and feel free to email me or send a comment into my blog. Yeah, thank you.